Okay, we're now ready to look again at arithmetic series. And in particular, what we're going to look at this time is when you add up the terms in an arithmetic series, how can we jump directly to the answer instead of having to add all of them up by hand? So how do we find the sum of an arithmetic series? What is an arithmetic series? It's just a arithmetic sequence. It's a sequence where you add a fixed amount to get from one term to the next each time. And if you put plus signs in between them, if you add those things up, then you get some answer. And it's not totally clear, aside from adding them up by hand, how to find the sum, the total. That's fine if your arithmetic series only has a couple of terms in it, but if your arithmetic series has a lot of terms in it, then it's a pain in the butt to have to add them all up by hand. Even using a computer, that's a pain and uses a lot of computing resources. There's essentially a trick to doing this which allows us to come up with a formula that will just give us the sum of an arithmetic series. And the trick is somehow the key to remembering the formula. So for myself, I always remember the trick, and I have to figure the formula out each time I do this. Very famously, this was supposedly figured out by a very troublesome young man in his elementary school days, a mathematician named Gauss, and he was given the following problem. The teacher gave the class, supposedly, the following problem on the board. The teacher said, find the sum of the first 100 integers starting from 1. That is to say, think about adding up the numbers 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to 100, and what's the total? And the teacher apparently, apocryphally, the legend has it that he gave this in order to sort of get the class off his back for a little while, give him a little quiet working time, because he figured this would take them a long time to answer. And within just a couple of minutes, apparently, supposedly, Gauss had come up with the answer and had explained how he got it so quickly. So we're going to follow Gauss's idea here. We start by writing down all of this is, let me see, the sum that we want to find is 1 plus 2 plus 3 plus 4 plus ... plus 98 plus 99 plus 100. Why am I writing down so many of them? It'll come in useful in a second. Here's the key idea, the one that's really useful, is we're going to write all of those same numbers down again in backwards order underneath these ones. So let's write them down again. So 100 plus 99 plus 98 plus 97 plus ... plus 3 plus 2 plus 1. Now, if we want to find the sum of the top row, say that thing is equal to some number, let's call our answer capital A, well, the sum of the bottom row is also going to be equal to capital A, and so the trick we're going to use is we're going to add up both rows all together, and we're going to get 2A, and whatever answer that we get for those two rows being added up together, we're just going to divide it in half in order to get this number A that we're after. Okay? And it doesn't seem like we've helped ourselves any because we now have to add up twice as many numbers. Is this even a useful thing? But this was the observation that Gauss made that is so handy. If we look at these and we add the first number in the top row to the first number in the second row, 1 and 100, we get 101. Now let's add this next number here, 2 to 99. 2 plus 99 is equal to 101. 3 plus 98 is equal to 101. 4 plus 97 is equal to 101. And ... If we keep going, then you'll notice here 98 plus 3, that's equal to 101. 99 plus 2 is 101, and 100 plus 1 is equal to 101. They're all equal to the same thing. And how many of them are there? Well, we started with 100 numbers. We added on these 100 numbers, and so there should be 100 of these. 100 of these. So what's the total? Well, there's 100, and they're all equal to 101, so this the total is 100 times 101, which is the number 10,100. And that's equal to twice the sum that we wanted. So what is our answer for the sum of the numbers from 1 to 100? Well, it's half of that, so our answer is that 10,100 divided by 2, which is 5,050. And this was the answer that Gauss presented to his teacher just a couple of minutes after the teacher asked the question. Okay, the idea here is the important part, which is we wanted to find the sum. So what did we do? We took the sum twice, once in the forward order, once in the backward order, and by doing that, what we ended up is by pairing them up, we got a bunch of numbers that were all the same. And we know how to add up a bunch of copies of the same number. We do it by multiplying. Then just as a last thought, divide the result by 2 in order to get the answer for just one of these sums. All right, we're going to be using that in the future to get a general formula for adding up any arithmetic series. You might note before we move on just that this is an arithmetic series. It has its initial term is equal to 1. And the common difference, the amount that it increases by each time, is that you add 1 each time. So this is A1 is equal to 1, and D is also equal to 1 in this example. That's it for now. We'll do one more set of examples and we'll be done for today.